In this video, I am going to practice some sampling distribution of proportion with you. So information on a packet of seed claims that the germination rate is 92%. There are approximately 160 seeds in each packet. Discuss of each condition required to use sampling distribution of the proportion seed will be germinate. So the condition is independent. So each seed is going to be germinate independently, and the seed is going to be random. Now it's the success and failure condition if that matters. So m times p totally is 160 seeds, and the germination rate is 19.2. So this one is equal to 147.9.2, which is greater than equal to 10. The success condition is met. So now the failure condition is equal to 160 times 0.08, which is equal to 12.8, which is greater than or equal to 10, greater than 10. So that means all these conditions are met. So yes, we can apply our normal model to the sampling proportion distribution. Define the sampling distribution model and its parameter. So we want to let p hat be the proportion of the seeds that germinate out of the 160 seeds. And by the property, we know that the mean of the sampling distribution proportion is equal to the actual proportion, which is 92%, and the sigma, the standard deviation of the sampling distribution proportion, is equal to the success rate times the failure rate divided by the sample size, and we take square root of it, which is square root of 0.92 multiply 8% divided by 160 seeds, which is 0.02145. I calculated by calculator. So that means our p hat follow a normal distribution with 0.92% of the mean, and the spread out, which is the variance, the standard deviation, is 0.02145. Sketch and label the model. So the model in the middle is going to be 0.92. The first standard deviation is we adding 0.021 to that. Let's say this is approximately 0.02. So I have a 0.94 for the first standard deviation. The second deviation is going to be 0.96. The third deviation is going to be 0.98. Subtract 1 is 0.90. 0.88, and then 0.86. These should contain most of your data. Okay, that's our normal model. And now, what is the probability that more than 95% of seed will be germinated? So the probability of the sampling distribution greater than 0.95 equals to, now look at the graph that we have. So this should be our 0.95, so it should be this area, which is in between the after the first standard deviation, and we can use our GeoGebra to calculate that. So mu is equal to 19.2. This is equal to 0.02145. I try to use as much accuracy, as precise as possible when I calculate that, so I will get a more accurate answer. Okay, so we want this to be greater than 95%, not 85. So, 95. So is 8.1%. So that means is 8.1% that more than 95% of the seed will be germinate. Next one, would it be unusual for only 140 or fewer of 160 seeds to germinate? Explain why. So now we can try to figure out only 150 or fewer of 160 seeds. So let's look at 140 out of 160. That is 0.875. So 0.875 is less than 0.875. I'm going to use some more contrast. 0.875 is approximately here. It's already outside the 2 standard deviation. That means very less likely. It's an extreme value. But we can also check with our GeoGebra to get more accurate answer. This is our estimate. Now let's take a look. So 140 seed, which is they have the same model, which is approximately 87.5% of seed will germinate, and we want it to be less than. So it's 1.8%. So in this case, when the p-hat, which the probability of the proportion that germinate, we want it to be less than 0.875, is equal to 1.8%, which is very unusual, right? Okay, so that's it for this practice. We will do more practice in the class. Let me know if you have more questions.